Yes, welcome you all for another beautiful presentation on oscillators. In today's presentation, I would like to explain you or give you a brief information on oscillators. Oscillators is one of the beautiful topic under electronic devices and circuits, right? What is an oscillator? Oscillator is nothing but it is an electronic circuit which provides the sinusoidal output, the sinusoidal output, right? So the oscillator will generates the oscillations on its own. That is what a oscillator actually, right? So oscillator is an electronic circuit that gives sinusoidal output, that you should remember. Okay, so otherwise you can say it can gives the AC output actually. It gives AC output in the form of waveform, in the form of sinusoidal waveform. You will get normally the sinusoidal waveforms like this. Wherever it needs, we will use these oscillators actually. One of the brilliant topic in electronic devices and circuits, right? This is AC output will be provided by the oscillator, right? Oscillator is nothing but it is a circuit. Basically the main important of this oscillator depends on the type of feedback we use in the circuit, right? The type of the feedback which we use in the circuit. Actually oscillator is nothing but an amplifier circuit only, right? Oscillator is nothing but an amplifier circuit, or otherwise I will briefly give you a small diagram of any amplifier circuit so that you can easily better you will understand about this particular circuit. As I already explained in our earlier presentations, if you recall, for any electronic circuit, especially which uses the feedback that will be in the form of this, right? Just I will explain you for your quick reference. It will have different stages, right? This is basically an amplifier, right? This is basically an amplifier, and from which we will take the corresponding output here. This is our output basically. This is my input actually, right? This is the summing point. This is the summing point, or otherwise you can say it is a comparator also. Sometimes this particular called as a comparator. It compares actually with what? So here this is basically a feedback network will be there, as we have seen in our earlier presentations. If you recall, this is my feedback network actually, right? This is my feedback network, and let us say for this amplifier the gain of this amplifier is A, and the gain of the feedback network is denoted by the letter beta, and here the part of the output is given back through this feedback network to this summer, right? My input is always plus actually. This is my input. Normally if you say if the input is voltage, then I can write it as V suffix I, that is my input voltage. I stands for input, V suffix input, otherwise you can say, and this is my output, or you can say V suffix V out. Clear? And so part of the output I am feeding back through this feedback network, and I am giving to this summer, or otherwise you can call it as a comparator. This is summer, or otherwise a comparator, right? Comparator or summer, you can write anything, summer. Remember here one important thing I would like to mention here is that here this is the feedback network. The part of the output I am giving back through this feedback network, and I am giving to this summer. Here how I am feeding it is very important. How the output through this feedback network I am connecting this summer, plays an important role. Okay, if I take the positive sign here, means my feedback, now my feedback signal is positive. It means that I am using a positive feedback. This plus sign here indicates we are using a positive feedback in this circuit, right? So if you use this positive feedback, you know, positive feedback, then this particular will act as an oscillator, right? In oscillator, so always remember that in oscillator it uses positive feedback. Very important point. Positive feedback, it uses positive feedback in the amplifier circuits. It uses positive feedback, or oscillator circuits will use positive feedback, whereas the amplifiers, whereas the amplifier uses negative feedback, right? Amplifier uses the negative feedback, whereas the oscillator uses the positive feedback. Understood? That is very important point. It uses positive feedbacks only. Whatever may be the oscillator, it could be any type of oscillator, it uses definitely a positive feedback must be provided in that, right? Right, very nice. Then, so my, this is my part of output. So this is what my V naught actually, right? This is my V naught coming from here, arrow mark in reverse direction, and now beta. So once this V naught is feeding, or it is passing through this feedback network, now what could be the output of this network? So the gain of the this particular network, the gain of the network multiplied by its input, means beta times into V naught, that is the output here. That is beta times V naught comes as output here, and this beta times V naught I am feeding to here. Then here the error signal will be comes out here. This is error signal, you can say error signal, V suffix E you can write, V suffix E, error signal. Now if you take the ratio V naught by Vi here, V naught by Vi, means if you take the ratio of output by input with the effect of this feedback, you will get that A by. So this is the positive feedback. For positive feedback, what you will get normally? 1 minus A beta. Remember that. This is the formula. That is the voltage gain, or the output by input, or the transfer function, also called as the transfer function. But here in this particular concept, under this oscillators, we will call it as a voltage gain. Output voltage by input voltage gives rise A by 1 minus A beta, because of this positive feedback. If it is negative feedback, then you will get A by 1 plus A beta, 1 by 1 plus A beta, right? So this is very important formula that one should remember. V naught by Vi is equal to A by 1 minus A beta. If you refer our previous presentations, you can have how the particular equations can be derived. It is very simple actually, right? So if you consider for this amplifier, what is the output? V naught. So for this up to this particular amplifier, what is the input? VE. Consider VE as input. So for this, if you write the expression V naught is equal to A into VE, that is expression number 1. V naught is equal to A into VE is the expression number 1. Next, the expression number 2 is VE is equal to Vi plus beta times V naught. Only 2 expressions, right? Only 2 expressions. What is the first expression? Here, from here, V naught means output is equal to A into VE. A into VE. That is expression number 1. Now, what is the expression number 2? VE means error signal. Error signal is equal to, so input voltage Vi plus, because it is positively feedback, beta times V naught. This is equation number 2. Now you substitute this equation number 2, that is VE is equal to Vi plus beta times V naught. This VE value total, if you substitute here in equation number 1, then bring the ratio of V naught by Vi, then you will get this ratio actually. If you substitute equation number 2 into equation number 1, and finally you will take the ratio V naught by Vi, you will get this particular. This is very important, right? Now, if you see the denominator part here, 1 minus A beta, what is A? A is the gain of the amplifier, beta is the gain of the feedback network. So, what is A into beta? That is the product of the gain of amplifier as well as the feedback network. So, there is an important relation between the product of this loop gain. Okay, then that is called as loop gain also. A into beta is called as the loop gain, right? Let us see. I will write once again here. So now with the feedback, with the positive feedback, you will get the voltage gain. What is that? V naught by Vi, means output by input gain, is equal to A by 1 minus A into beta. Clear? This is with the positive feedback, you will get this, right? Here in the denominator part, this implies 1 minus A into beta. You can take magnitude also. Sometimes your beta in the feedback network, beta is the gain of the feedback. Sometimes the feedback may have different elements also, means it may have some RC components, means resistance and capacitance. Sometimes this feedback network may contains the inductances as well as the capacitances also, right? In that case, normally we will consider this product, we will consider as in modulus, okay, in modulus, right? Therefore 1 minus A beta equal to 0. This implies 1 is equal to magnitude of A beta, means the loop gain must be 1. The loop gain must be, means the product of A into beta must be equal to 1, and if you take the angle between these two, means angle of A into beta must be 0 degrees, or otherwise it is 360 degrees. These are the two conditions that we can obtain from this particular relation, important relation. So one is the magnitude of A beta must be equal to 1. The magnitude of A beta is equal to 1, and the angle of A beta, the angle means the angle between A into B should be 0 degree, or otherwise 360 degree. These two equations are called as Barkhausen criteria. What is Barkhausen criteria for oscillations? So for any oscillator circuit, in order to get the oscillations at its output stage, then that oscillator circuit should satisfy the Barkhausen criteria. What is the Barkhausen criteria? The criteria says that the product of the gain, amplifier gain and feedback gain, must equal to 1. So it means that you must select the gain of the amplifier as well as the gain of the feedback factor in such a way that if you take the product of those two gains, you must get the value 1. If it is satisfied, automatically your angle will be adjusted to either 0 degree or 360 degree. So directly that amplifier circuit will definitely satisfies the Barkhausen criteria. Thereby that circuit is satisfying the Barkhausen criteria. That's why you will get the sustained oscillations at the output. You will get the oscillations. You will get the oscillations. Then that particular circuit can be called as it is an oscillator circuit. Right? So in this presentation, this is what I want to present actually. What is the Barkhausen criteria? What is the oscillator? What is the type of feedback in any oscillator will be used? And this is the condition. This is the condition required for an oscillator. Very, very important bit actually. What is the Barkhausen criteria? Explain. Then you need to explain these two conditions. How you can explain? From this definition, V naught by Va is equal to A by 1 minus A beta. From this, so if you equal this denominator part to 0, then 1 is equal to A into beta, but sometimes beta may have some complex values also, complex values. Normally, it will consist of any resistance elements or capacitive elements or inductance also. That's why normally we will consider the magnitude in terms of the magnitude. right? So remember these two conditions, these are called the Barkhasan criteria. Once this condition is satisfied, then only the circuit will gives the output as an oscillations, sinusoidal waveforms, right? So this is what the brief information about this particular oscillators. So in the next presentation, I will cover what are the types of oscillators we will have. As far as our subject is concerned, we have low frequency oscillators as well as high frequency oscillators. That we will see elaborately in the next presentation, right? I hope you understood this particular point very well, and I request you all to comment on this particular topic. If you have any doubts or if you have any further information, if you need more information, then definitely you feel free to give your observations and suggestions, comments on my channel, right? And also do not forget to share to your friends so that this information should be passed to many of the students, so that many of you should be benefited from this, right? So with this, I will finish off today's presentation and we will meet in the next subsequent presentation. Have a good day.